Hey everybody, Mr. Gravi here, and hopefully you took some notes on that recap of the Desmos, and you're starting to get a little bit of a feel for what this idea of a limit is. The purpose of this video is to go through some actual problems. So these are the types of problems that I'm going to expect you to be able to do relating to limits. And just like the Desmos, we're going to start out by thinking about this idea of limits by looking at graphs. Okay, so it's going to be about limits graphically, looking at graphs. Okay, we're also going to do them numerically and algebraically, but those are different videos. Okay, so stick with me here. The graphs we look at when we do limits graphically are usually weird looking graphs. They're actually piecewise graphs. You may or may not have learned about, but you don't really need to know. But they're weird graphs. They're going to have holes in them. They're going to have jumps in them. That's what's going to kind of make these questions interesting. Okay. What I want to do here is just go through some problems here. Okay? So please, let's start out with the ones that are not limits. This is just saying f of -4. It's just saying what's the y value when you put it in an x value of -4. Okay, nothing with limits, none of this weird new ideas. Go to an x value of -4. What is the y value? So be careful here. Don't say 2. Because the y value isn't 2. There's a hole there. So what's the y value? There is no y value. Okay? That means it is undefined. Okay? When functions don't have a y value, you say undefined. Okay? You guys know that. Cool. Let's do this one. I don't want to do the limits yet. Let's just do the fun. F of 1. What's the y value when you put it in an x value of 1? X value of 1, what's the y value? Well, that's the whole. So I use this point, the y value is 4. Okay. So when you put in an x value of 1, the y value is 4. Let's do this one. Not a limit again. Just f of 6. What's the y value when you put in an x value of 6? Be careful. When you put in an x value of 6, the y value, oops, sorry guys. The y value is, I'm not looking at the hole, I'm just literally, where's the dot filled in? It's filled in at 2. I didn't use any new crazy ideas there. Those weren't limits. Those were just the f of ones. Now let's talk about the limits. Start with this guy. This is saying, tell me the y value. Limits are always asking you for the y value. Tell me the y value that I get close to as my x value approaches -4 from the negative side. What is -4 from the left? Okay, the negative up there means from the left, a positive up there means from the right. Okay, so it's got a little mini negative sign. So I'm going to say as my x gets close to -4, specifically from the left side, what does my y get close to? Okay, so as my x gets close to -4 from the left side, so I got to start over on the left of it. I'm going to get closer and closer and closer to -4. What are my y values getting really close to? Well, they're getting really close to 2. Okay. The fact that there's a hole there does not matter. We'll say that again. Limits, when you're evaluating limits, it doesn't matter if there's a hole or if it's filled in. What happens if this was filled in? Nothing would change. Nothing would change. What happens if that dot was filled in down here? Nothing would change with the limit. Limits don't care about actual points because they're just talking about what happens as you get close to that point. They don't care what's happening at that point. They care what's happening near that point. What's this saying? Let's look at this. Oh, it's got a little plus there. What happens to our y values as our x values approach -4 from the right side? Okay. Well, I'm going to approach -4 from the right side. What are my y values getting close to? They're getting close to 2. Because as I approach -4 from the left and as I approach -4 from the right, both of those are approaching the same y value. They're both getting close to 2. I'm allowed to say that the limit as x approaches -4 in general is 2. A little phrase you usually say is like, if the left hand limit, which is what we call it, the little negative there, if the left-sided limit or the left-hand limit and the right-sided limit or the right-hand limit agree with each other, if they're the same number, then the overall limit is that number. If these two guys disagree, though, then we got another situation there. That means from one side we're approaching one number, from the other side we're approaching the other number, and that's messed up. And we'll see that. They agree? Well, then the overall limit is just that number as well. Please note, it's different than what f of negative 4 is. Your limit as x approaches negative 4 and f of negative 4, sometimes they're the same, sometimes they're different. If they were always the same, then we wouldn't even be doing this, right? Let's do these ones. Limit as x approaches 1 from the left. Okay? As my x value gets close to 1, but I gotta come from the left. So I gotta trace my graph, and I gotta come towards 1 from the left. What y value am I getting close to? 4. Notice I'm only looking from the left of the graph. What happens as I approach 1 from the right side? Well, if I'm going to approach 1 from the right, that means I'm going to come from this side. And as I approach the x value of 1, my y values are getting close to negative 2. Okay? I hope you're right now thinking, uh-oh. As I approach 1 from the left, I get close to 4. But as I approach 1 from the right, I get close to negative 2. So what happens overall as I approach 1? I don't know. It depends on whether you come from the left or the right. If you're coming from the left and the right, you're coming towards different numbers. That's a problem. That's a problem, that's a problem, that's a problem. Okay? What that means is there's no overall agreement about what y value you're approaching. Okay? From the left, you're approaching 4. From the right, you're approaching negative 2. You don't, like, average them or pick something in between or just pick. No. You say there is no limit. There's no agreement. The limit does not exist. Please note that when you get no answer for evaluating a function, you say it's undefined. When you get a limit that doesn't have an answer, you say it does not exist. Okay, so there's a difference there. I do want you to know those two different vocabs. Functions are undefined, limits do not exist. Okay. All right, let's do one more of these. The limit as x approaches 6 from the left. Okay, so as my x values get close to 6 and I come from the left, my y values are getting close to 5. Cool. As I approach 6 from the positive side, from the right side, as I approach 6 from the right side, my y values are getting close to 5 as well. Which means overall, my limit is 5. Why? Because as I approach it from the left and I approach it from the right, both of those are 5, so as x approaches 6 in general is 5. Please note that if I ask you this question by itself, you actually need to think about these two questions. Because that's the way to tell if this has an answer. Is if from the left and from the right, you get the same thing. So you know, this time I asked you these specifically, but you need to be thinking about these when I ask you this. It's really the idea here. Okay. All right. You guys want to try this one? Yeah. Okay, cool. You go ahead and pause. Here's another graph. I want you to give these a try, and I'll go through them with you after. Cool. Pause. Actually try these. Thank you. Okay. So these are the answers I got here, and I'm going to run through them with you guys here. So first one here says, what happens to our y values as our x values get close to 1? Now notice there's not a plus or a minus there. So it's saying as you get close to 1 in general. What you need to do for this is think about as you approach 1 from the left and as you approach 1 from the right, and make sure that they're giving you the same number. You need to do that. Okay, so you need to be thinking, as I get close to 1 from the left, I'm getting close to a y value of -1. As I get close to 1 from the right, I get close to a y value of -1. From the left and from the right, I'm both of those are approaching -1. So overall, the limit as x approaches 1 of f of x is -1. And you need to think about both sides. The common mistake is just to look at one side. Same thing here. Just saying, what happens as I get close to 3? What happens to my y values? I need to look from the left. My y values are getting close to 1. From the right, well, they're also getting close to 1, so overall the limit is 1. For this one, just have to think about as I get close to 2 from the right. I don't need to think about from the left. The plus is just saying from the right, my y value is getting close to 1. These two, evaluating a function. What's f of 1? What's the y value when I plug in the next value of 1? Not approaching 1. Don't be thinking about getting close to 1 here. This is just saying, what's the y value when you plug in the next value 1? Go to 1, where's the dot? It's at 2. This is really asking you, where's the dot? F of 4, be careful here. There is no dot per se, but where's the filled in? Remember, filled in line is really the same thing as a dot. There is a dot here. A line is a bunch of dots, right? Like that's what a line is a bunch of dots put together, a bunch of points put together. Okay. So when I put in the next value of 4, what y value do I get out? 2. Don't be looking here. That's nothing. Open circle. I got one more for you here. There is 2 extra problems I want you to add on here that are a little bit confusing. 3 more. The limit as x approaches -3. And 2 more. And the limit as x approaches -1 from the right. Okay. Go ahead and pause. Give all of these a try based on this graph. Unpause and we'll go through them again. Cool. Okay. So first thing, it's kind of hard to tell some of the y values here. So I did a little bit of estimating. So if you had to do a little estimating, that's totally okay. So your answer is because that might be a tiny bit different for a couple of them. Okay, let's run through these. So as I approach -3 from the right, so I get towards -3 from the right, I'm approaching a y value. This is one of the ones I estimated. That's at around 0.7. Okay. As I approach 2 from the left, as I get close to 2 from the left, my y values are getting close to -0.5. As I approach -2, now notice there's no plus or minus, I need to think about from both sides. So my limit as x goes towards -2, as x approaches -2, I'm thinking about from the left and from the right. In both cases, it's just, there's nothing weird going on with the graph. In both cases, it's going towards 0. Okay, so overall, my limit is 0. For this one, as I approach -3 from the left, again, that little minus means I'm approaching it from the left. So as I approach -3 from the left, my y values, it looks like, are getting really close to -0.7, -0.9, -0.8, something like that. F of 2. What's the y value when the x value is 2? Go here, go to the point is at -1. Remember, this is looking at the point. What's f of -2? Go to -2, look at the point. In this case, there was no point, but that just means look at the line. The line is at 0. Okay. What happens as I approach 2 from the right? As I get towards 2 from the right, I'm getting close to -0.5. And when I'm trying to think about this, the overall limit as x goes to 2, I already looked at from the right and I already looked at from the left. So overall, since those two things are the same, they agree with each other, my limit as x approaches 2 of f of x equals -0.5. I can say that because from the left and from the right, I'm getting out the same thing. Similarly here, I'm looking at the limit as x approaches -3. I already did the from the right. Oops, sorry. And I already thought about from the left. But in this case, different numbers. From the right, I was getting closer to 0.7. From the left, I was getting closer to negative 0.7. So overall, I'm just saying as I get closer to -3, what is my y value getting closer to? Does not exist. Sometimes you see people say DNE, does not exist. Please don't say undefined. We're doing a limit. Limits either are numbers or they do not exist. Last one here is weird. What happens as I get close to -1 from the right? Well, if you look graphically, what do I have at -1? I got a big old vertical asymptote. Okay, something we saw when we talked about rational functions. As I get close to -1 from the right side, this graph's kind of weird looking, but you get the idea. I'm going up and 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 up. I'm not getting closer to a number. I'm getting closer to infinity. Okay, and we are going to see that sometimes where if you have a vertical asymptote, as you approach a number, your y values might not be approaching an actual number as much as they'll just be going up and up, in which case we say equals infinity, or going down, 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 in which case we say equals -infinity. We're going to do lots of practice with this. I know it's kind of a weird idea, but I hope you're starting to get a little bit of a better understanding of these limits graphically. Cool. All right, thanks for watching, guys.